All right, in example 1, we're going to show that the function f of x equals x squared satisfies the mean value theorem on the interval from 0 to 2. Then find a solution c to the equation f prime of c is equal to f of b minus f of a divided by b minus a. So to show that a function satisfies this, first we need to make sure a couple things. We need to make sure that our function is continuous. So let's look at f of x equals x squared. Well, we know just real quick. Okay, it's continuous. Check, it's continuous. The next thing I want to point out is that we are on a closed interval. So because we're on a closed interval, the mean value theorem so far checks out. So to show that it satisfies means that we can show that the derivative at a point is equivalent to the average rate of change. So all we need to do is solve for the slope of the tangent line. So let's go ahead and do that. We have that f of x is equal to x squared. So f prime of x is equal to 2x. This means, well, we want to find f prime of c. So f prime of c is going to be equal to 2c. So we have that 2c is equal to, now we need all these parts. Well, f of b is equal to this right here, which is b, f of 2, which is 2 squared, which is 4. This right here is a, so f of a is equal to f of 0, which is just 0 squared, which is 0. So you're going to get 4 minus 0 over 2 minus 0. Now keep in mind, this whole thing is equal to slope any way you cut it. So we get that 2c is equal to 4 divided by 2. So 2c is equal to 2. This tells me right here that this is m. This is our average rate of change from the points 0, 2. If I were to just graph this very quickly to show you what I'm talking about, here's the graph x squared from 0 to 2. So the parts that are dotted are not included in my domain. And what this means is that if I were to draw a line that extends from here to here, the slope of this line is, in fact, 2. So what we want to do then is find the point here where this tangent line is parallel. Well, all we really need to do is solve for c. So right now what we just did, we showed the mean value theorem holds. But we get c is equal to 1. Okay, so c is our x value. So this is c right here, which is equal to 1. So what we need to do is actually find and make sure that the slope is the same both ways. So we know that the slope is equal to 2 from here. So because of this, we know that the average rate of change is 2. So we need to show that f prime of c is equal to the average rate of change. Rate of change. So c was 1, so f prime of 1 is equal to 2 times 1, which is 2. And if we look right here, and we look over here, they're the same. So not only did we show that the mean value theorem holds, we actually solved for the c value. So I'm going to write a little conclusion statement. And I'm going to write the tangent line to f of x equals x squared at x equals 1 has a slope of 2 and is parallel to the chord, and you can say chord or secant line, joining A, which has coordinates 0, 0, and B, which has coordinates 2, 4. This piece right here, this is proving or showing that the mean value theorem holds. Okay, so now what I wanted you to do is do the same scenario. I want you to show me the mean value theorem holds, but on the interval 4 to 9 with the function the square root of x. So go ahead right now, take a second, and show me that it holds. All right, let's see what we got. So the first thing we need to do with the mean value theorem is we need to write down what we want to show. And we want to show that f prime of c, the derivative at a point, is equal to the average rate of change. So let's just start identifying things. Here is A, and here is B, so I know I'm going to need f of A and f of B. So f of B is equal to f of 9, which is the square root of 9, which is 3. Then we get f of A, which is f of 4, which is the square root of 4, which is 2. Now look, I'm going to need the derivative. So let's go ahead, let's take the derivative. If f of x is equal to the square root of x, then f prime of x is equal to, and I'm going to rewrite this as x to the 1/2. This is 1 over 2 square root of x, or 1/2 times x to the power of negative 1/2. So I want to find f prime of c, which is 1 over 2 the square root of c. Now you don't really have to plug in the c. You could just leave it as x. I prefer to leave it as c and then plug that back in to find the derivative at the point because it tells me that I'm finding a numerical value. But if you don't want to do that, that's okay. So we get 1 over 2 times the square root of c is equal to 3 minus 2 divided by 9 minus 4. So 1 over 2 square root of c is equal to 1 divided by 5. And there's a couple ways to solve this. You can cross multiply. What I like to do is notice that these are the same, so these must be the same, which is the same as cross multiplying. So 2 square root of c is equal to 5 over 2. Oops, I'm just sorry. The square root of c is equal to 5 over 2. So c is equal to 25 over 4 by squaring both sides. So there's my c value. And again, when I'm all said and done, remember that this 1/5 is my average rate of change. So when I take this c value and plug it in right here, I better get 1/5. So f prime of 25 over 4 is equal to 1 divided by 2 times the square root of 25 over 4, which is equal to 1 divided by 2 the square, or times 5/2. And this is equal to 1/5. So we get the same derivative, or same value, if we take the average rate of change or if we take the derivative at the point. So what we need to write is that the tangent line to f of x equals the square root of x at x equals 25 over 4 has a slope of 1/5 and is parallel, and that's the shorthand for parallel, to the chord joining A which is the coordinates 4, 2, and B, which is the coordinates 9, 3. And there you go. That's how you show that the mean value theorem holds.